Hi and welcome to another video lesson. Today we're going to be talking about the intermediate value theorem. Okay, so the intermediate value theorem basically just tells you that on a given interval of a and b, there will be a function value between f of a and f of b. So in words, if f is continuous, this is the first thing that you have to do is solidify that f is continuous. Okay, you have to mention this in most of the class, in most of the examples that we give you in AP Calculus. So we got to say first it's continuous, then f will be any value between those two endpoints, f of a and f of b. So let's take a look at that. So if I draw my y-axis, my x-axis, and I just have a continuous curve, just a nice one here, I know that this point right here, let's say that the x value is a, and I come out here all the way out to b. So this coordinate would be a comma f of a. So this value on the y-axis would just be f of a. And if we substitute it in b, then this point would be b comma f of b. So that means that f of b would be at that y value. So what the function, what the IVT says, intermediate value theorem says, is that there exists some c, so that if I do substitute in some c value, and it's between a and b, then the output has to be somewhere between f of a and f of b. Okay, and that's all that says. It says that no matter, so if I do have a function value somewhere in this pink, then there does exist a c value that I could plug in. All right, so that's exactly what the intermediate value theorem says. So let's take a look at the examples. So this says to assume that f of x is continuous. In a typical problem, I will say that it's continuous, but this says to assume that it is. On 0 to 4, f of 0 is 1, so this point right here is 0, 1. And then 4, 16 is this point out here, 4, 16. And it says that we need to explain why there must be some value so that I get 8 as a result. 5, 6, 7, 8. So we can tell logically that 8 is between 1 and 16, right? So we're just going to do our best in explaining that by using the IVT. So here's the way we'll do that. We'll say that f is continuous. The next thing that we'll say is that 1 is less than or equal to f of c, which is less than or equal to 16. So basically what we've just said is that this value 8 is between 1 and 16. So by the intermediate value theorem, there is a value x equals c, so that, sorry, I got a video going in the background. Okay, so I apologize for that. So that f of c equals 8. So basically what you said was f of c is between 1 and 16. So by the intermediate value theorem, there must be some c value. There must be some c value so that f of c is 8. Okay? All right, so let's continue. Let's look at a table. So assume the table represents a continuous function. It says continuous, okay? We typically, when we do an AP calculus problem, I want you to also write that down. Okay, explain why there is some number c on the interval from 2 to 5. So this time it doesn't say to go from 1 to 6, just 2 to 5, such that f of c is 6.7. Well, f of 2, sorry, this is g. So I'm going to go ahead and just write g is continuous, just to get you guys in that good habit. Okay, well, we know that g of 2 is 4 based on the table, and g of 5 is 10 based on the table. And now we see that 4 is less than or equal to g of c, which is less than or equal to 10. And basically what I've just said was 6.7 is between those two values. Another way you could write this is that you could write that g of 2 is less than or equal to 6.7, which is less than or equal to g of 10. All right, just a little note. So either way is fine. But what I don't want to see you do is put all numbers in or all functions in. You'll have to at least use either two numbers in this expression, or in this inequality, or two function values in that inequality. And I accidentally said g of 10, that's g of 5. All right, so since g of c is between those two, we can say that by IVT there exists an x equals c, so that f of c equals 6.7, because 6.7 is between 4 and 10. And again, I used f, and there's no f in this problem. That's g. All right, so a third type of problem might be with a function. And this problem says to show that this equation has at least two real zeros between 1 and 4. Well, that's interesting. Okay, so what I want you to do is grab your calculator, and let's go ahead and basically make a table for x equals 1, 2, 3, and 4. All right? So here's my calculator, x to the third minus 5x squared plus 3x plus 6. And I'm going to push second table, and I'm going to ask the table to report to me 1, 2, 3, and 4. So we're just making a little table there. Okay. So with that table, you can already tell that we have 1, 0. So let's go ahead, and it says to create a table of values to support our reasoning. So here's x and y. Sorry, let's call it x and f of x. We have 1, 2, 3, 4, 5, 0, -3, and 2. Okay, so there is a 0 at x equals 2 based on the table, right? Now, the problem though says show me that it has at least two real zeros. So is there another one? The answer is yes. We have at least one more answer. And here's the reason. What I can tell is that at x equals 3, the function value is negative. So here's basically a little picture of it. At x equals 3, the function value is negative, but at x equals 4, the function value is positive. So I know that that there must exist some value. I'm sorry, there must exist some x equals c on this little interval so that my output is between those two, right? So my output has to be 0 in this case, not just on that range. Sorry about that background noise. The bell's ringing, right? Okay, so here goes. We're going to say f is continuous based on the problem. Okay, well, it's continuous because it's a polynomial. Okay, all polynomials are. And then we're going to say that let's see, f of, let's say, you know what? Let's say that negative, let's say f of, good Lord, 3, f of 3 is equal to negative 3, and f of 4 equals 2. And we know that that's less than 0, that's greater than 0. So maybe we'll say, so f of 3 is less than 0, and that is less than f of 4. Notice how I used a number in the middle and then two functions this time. Okay? So if 0 is between those two, then by the intermediate value theorem, there is, or there exists, an x equals c so that f of c equals 0. You know what? I'm missing something. I should say there exists a value x equals c on the interval between 3 and 4. So I should probably add this on the interval from 3 to 4. And you know what? I should probably be more specific on all these other ones. So on this one, I should say on the interval from 2 to 5. By IV, there exists an x equals c on the interval from 2 to 5. By IVT, there exists a value x equals c on the interval from 0 to 4. Okay, so that's one little correction that I would make throughout the page if I were to re-record this video. So I've done my best to give you guys the intermediate value theorem, but a graphical interpretation, a tabular interpretation, and then one dealing with a function where you actually had to create your own table. So there you go. I hope you enjoyed that. If you have any questions, be sure to ask. Thanks. See ya.